All right, today with functions, we're going to look at domain and range. We want you to be able to identify what the domain and range for a relation in a function is and determine if a graph is a function or not. So domain, anytime you hear the word domain, that's talking about what's the x values for that relation or function. The range is then the y values for the relation or function. A function, as we looked at a little bit before, is a special relationship where each input has a single output. Okay, so in the examples here, this mapping we would say is a function because each of the inputs in our domain maps with exactly one output in the range. Okay, so that's an example of a function. If you're looking at a graph, then we want to use what's called the vertical line test. And the vertical line test makes sure that each input has one output. And so if you draw in vertical lines for the graph, you should only ever see your vertical line hit the graph at a single point. That's telling you that that input has one output. In this second example, if I draw a vertical line, say right down the y-axis, you can see it hits twice, here and here. And what that's saying is, for 0, there's a point at 0, 2, and 0, negative 2. So for this graph, we don't know what f of 0 is equal to. There's two outputs. Is it equal to negative 2? Or is it equal to positive 2? We can't tell exactly what the output is. If we looked at it in a mapping situation, if we had 0 here for our domain and our range over here, we have two lines coming out of 0. That's not a single output for this input. There's two outputs. That's not a function. Okay, so we want you to be able to state what domain and range is, looking at whether you got a group of points, a line, a graph, and so on. So for here, for our domain, we're looking at, again, what is the x values. So if we look over at this group of points, we want to try to pick out what are the x values located there. Well, if you got points, x values is always the first point. So our x values would be this set of points. So it'd be the set of points of -4, -3, 0, and 1. Our range is the y value. So now, and when you got ordered pairs, that's always the second number. So our range here would be those points. And usually they're written in order from least to greatest. So it looks like the smallest one there is -2, then 0, 1, and positive 2. All right, is this a function or not? If it's a function, when you're looking at a set of points, you're looking at, is there any repeated x values? So was any of our x values repeated here? No, they were all different, which means if they're all different, all the outputs are going to have, or each of those inputs is going to have a single output. So yes, this would be a function. You could also graph the points and look at the vertical line test too. All right, next one, state the domain and range here. Okay, so domain again is our x values. What is the x values spanned from this graph? Well, if you look down here on the x-axis, it looks like this graph goes from -3 here over to 4. Okay, so that means our domain would be all the x values, okay, less than 4, greater than -3. Now, the one last thing you got to kind of look at with this is, do we want to count those endpoints or not? With -3, it appears we do want to count it. We have a filled in point right at -3. So we do want to, it could be also equal to -3. But if you look at 4, we got an open circle here. We don't want to count we don't want to count +4. That's not part of the domain. There's no point actually at 4 there. Okay, for our range, now we're looking at what's the y values. So we're looking up and down now. What's the y values that this gets spanned from? Well, it looks like it goes from 7 down to 0 there. So our range, that's our y values. It's the numbers less than 7 and greater than 0. Now again, we want to look at, should we count those endpoints or not? Well, we know with our point on the bottom there, we do want to count it at 0. So it could be equal to 0. Our point on top, though, we don't actually have a point there. It's open, so we don't want to include the equals to. Is this a function? With these graph ones now, it's super easy because we can use our vertical line test. If we were to draw a vertical line anywhere, are we going to hit the graph more than once? No, we're not. So then, yes, this is a function. Each input has a single output. Okay, number 3. Okay, looking at this graph of the circle here, what are the x values and y values spanned here? So with x values, we're looking at what's the farthest point on the left and the farthest point on the right. Farthest point on the right looks like 3. Farthest one on the left looks like -5. So our domain is the points less than 3, greater than -5. And it doesn't look like we want to include either of those 2 points because right at those points we see there's an open circle there. So we don't want to count those points. All right, now for our range. What's the range values that are spanned here? Okay, so now if we're looking y's, what's the lowest we see? Lowest looks like 3. What's the highest that we see? Highest looks like 5. Okay, so we want all the y values in between there. Okay, so we got all the y's have to be less than 5, and they're all greater than -3. And here we do want to include, because there is a filled in point there, there's no open circles on that graph. However, if you look at this graph, we do have these 2 open circles here and here, and that's at 1. So this graph's not actually, it doesn't actually have a y value at 1. So we would also include the fact that y cannot equal -1 there because there's no point there. Is this a function? Well, let's check our vertical line test. If I draw a vertical line somewhere, does it hit more than once? Yeah, it does. It hits twice. This is not a function. Okay, that input has 2 separate outputs. That is not a function. Okay, going to the back, a couple more of these examples here. Domain and range. On this one, why don't you pause the video and see if you can try this one out and see what you get. All right, well, let's see what you came up with. On this one, domain, you got, that's your x values. You can see the smallest one is -2. Okay, now on the other end, this one's a little bit different because you see the arrow actually keeps going here. So if it keeps going, eventually this is going to keep going up here. Every x value is going to get eventually accounted for. So on this one, since our graph keeps going, there is no right hand side of this where it stops. We can just write it with a single inequality. So here we would say our x values are all going to be, compared to -2, are all going to be bigger than that. We don't want to include -2 because we see we got an open circle there. So we would say the domain is all the points bigger than -2. Range is your y values. Okay, now again, this graph is going to keep going upward. We're going to hit every y value possible as we keep going here. So the y values will keep going forever in the upwards direction. But there is a lower end here where it doesn't keep going, and that looks to be at -2. So all our y values compared to -2 are all bigger than that. Not equal to, because again we got an open circle there. Is this a function? Let's check. Does it pass our vertical line test? Yeah, doesn't matter where we draw it. This one's a function. Okay, two more here. This one is what's called a piecewise function. We'll get into more of that later, but it's separate pieces here. We want to, again, state what's the domain and range. So let's start with our x's. On the left, looks like the outermost one is -4. Now, it's all these points here. We hit an open circle. Is there a point at this value? Well, not there, but if we keep going down, there is a filled-in point there. So we do have a point at -1. It keeps going over. No point here, but if we go back up, there is a point there, so we're okay. And it keeps extending all the way to -5. So it looks like every point in between -4 and +5 are accounted for. So our x's are going to be less than 5, bigger than -4. -4 itself, no point. 5, though, however, does have a point, so we do want to equal to there. Okay, now let's check range. Range is your y value. So it looks like this line always stays at -2. That's the y value the whole time. There is no y values in between here and the next y value we see at 1. Okay, again, in between this one now and the one up here, there's no y values there either, but we do have some more y values at 3. So because these are just horizontal lines, there's nothing in between them. We would just list this range out as a set of points here. It would be the set of points of -2, because there's a y value at -2. There's y values at 1, and there's y values at 3, but nowhere else. So that one would just be a set of those 3 points. Is this a function? Well, it's kind of a goofy function, but it is a function because it does pass our vertical line test. If we draw a vertical line, only hits once. Even if we go at one of these switchover points, there's no point here, but there is a point here, so we're still just hitting one graph. Only one graph. Here, again, at the switchover point, we're only hitting one point because that's open, so it only hits once. Anywhere we do, it only hits once, so yes, that is a function. All right, last one. What is domain and range of this graph? And this graph does keep going up in these directions here. So what is this domain and range? Okay, well, domain again is x values. What's the x values covered here? Well, you can see definitely between 2 and -2 everything is, but then our graph keeps going up. So as it keeps going up here, every negative x value is eventually going to get hit. It might be really slow going getting to all those x values, but with this graph being extended up, it will hit every negative value. Same thing on this right side, we will eventually hit every positive x value as well. And so since this graph covers every x value, we would say it's all real numbers. You can use the symbol for all real numbers, which is this, or write out all real numbers. Either way would be acceptable. Okay, for range. Range is your y values. Okay, and in this graph, with our graph going up, we're definitely going to hit all these positive y values all the way up, but not in the other direction. There is a lower end to this. The lowest this graph gets is -2. It never goes below -2, and since both arrows are going up, our range would be all the values bigger than or equal to -2. Okay, last part now, is this a function? Test it with our vertical lines. Looks like it. We never hit more than once anywhere. So then, yes, this one is a function. Okay, so now you're going to practice doing some of these domain and range on your own.